Welcome back to a new video lecture, and right now we continue the last class lecture, that is the estimation of slab culvert. Okay, slab culvert. Okay, so already we discussed the details regarding the estimation of earthwork excavation, first class brickwork, then the RCC slab. So here we concluded that last portion or last video lecture we concluded with this. So here please note down these values, that is the length it is going to be 4.8 and this breadth it is going to be 2.1. okay, so with these values we will continue, that is going to calculate the quantity of reinforcements required for this particular RCC work. So here if you observe that the reinforcements are arranged in this way, if you observe these reinforcements are arranged in this way such that this blue represents the main bars which are in straight bars. Okay, and here if you observe that the spacing is going to be 30 centimeter between these straight bars, and in between there is a cranked bar is also provided. Okay, cranked bar is also provided here. And if you observe that the red line or this represents the distribution bars. Okay, so and here we are providing this distribution bars at the top also, that is here just if you ask, here we are assuming actually we are providing two numbers here and here also two numbers to the top side for the supporting this cranked portion actually. Okay, so here you can observe very clearly how this main bars and these cranked bars are provided. Okay, and here if you observe that actually this distance it is going to be 30 centimeter, and if you observe that this distance it is going to be 15 centimeter, and it is mentioned here this cranked bar and this straight bars. And if you observe that if you want to calculate the total numbers of bars, you can calculate that is 4.8, that is the total length. That's I already mentioned that the cross section that is 4.8 and 2.1 slab dimension, minus this clear cover you have to subtract from both sides. So already we calculated all those things in the bar bending schedule. By this spacing of each one, that is 0.15, you will get 33 numbers. And if you observe that if you are providing this first one with this straight bars, the number which will be going to be more, that is if it is going to be 33, it is not possible to divide into 2. By 2 it will give some fraction values only. So this 70 numbers it is going to be the straight bars, and these 60 numbers are going to be these cranked bars or bent up bars. Okay, such that we will conclude. Okay, and now we move on to calculate the length of this bar, that is this straight bar length we will calculate. The total already mentioned this 2.1, and the slab height it is going to be 0.2, and if you calculate these values you will get total length it is going to be 2.1 minus clear cover, then you have to add 2 into 9 into D. Okay, so 20 mm diameter it is provided, so you can, the length it is going to be 2.38 meter. So you will get this value if you add up those values as 17 20 mm dia straight bars, and it's, if you check out this 17 multiplied by 2.38 you will get 40.46 meter. Now to calculate this estimation of this cranked bar or the total length of this cranked bar, actually the length it is going to be same, that is 2.1, and the height it is going to be 0.2, and the total length you can observe that 2.1 minus the clear cover, then there is an extra term, that is 2 multiplied by 0.42 into D. This is the general equation for the cranked cases. And for calculating this D, you can observe that in this diagram it is calculating from this center portion to this center portion. Okay, in some textbooks they are starting from here to here. Okay, so such that in such cases this can be 0.2 minus 2 multiplied by the clear cover, that is going to be 0.02 0.02. Then if you're considering from this center point to this center point, then you have to reduce this diameter. One diameter you have to take, that is 0.02. Okay, 0.02. Actually the diameter is going to be 20 mm diameter. Okay, so that's, you'll get 0.14. Okay, so with this value, if you multiply the total numbers, it is going to be you'll get 16, and 60 multiplied 2.49, you'll get 39.84, and total if you add up to 80.3, and if you take this d square by 162, you'll get finally 2.46, and if you multiply with this 8.3 multiplied by 2.86, 2.4346, you'll get 198.27. Okay, then we move on to the next one, that is the distribution bars. So if you observe clearly, you can calculate this value also, that is this 2.1, this distance is going to be 2.1, so you can calculate the total numbers. Clear cover you have to take. Okay, so clear cover, that is going to be 0.04. Then the span distance is going to be 25 centimeter or 0.25, then plus 1, you will get 9 numbers. And already I mentioned that we are also providing 4 numbers over this side. The top portion we are providing 4 numbers. And also don't confuse with this clear cover which we are providing. Okay, so to the both sides we are providing 40 mm likewise, and this top and bottom we are providing 20 mm. Okay, so if you add up these values, 9 plus 4 is 13, and if you multiply, you'll clearly get those values. So the total length, it is going to be 4.8 minus clear cover, it is going to be 2 multiplied by 0.04. Both the sides, it is going to be 0.04 or 40 mm. Okay, clear cover, it is going to be 40 mm. Then plus 18, that is 2 into, that is this cranked portion, 2 multiplied by 9, you will get this value. Then 4 you will get 4.9 meter, and this 9 multiplied by 4.9, you will get 44.1. Okay, there is d square by 162, if you use, you will get this final value, that is 39.49 kg. Okay, so actually this is the case of this slab which we are providing, and now we need to calculate the bearing coat. Okay, the estimation of this bearing coat, that is the, we are providing a 10 centimeter thickness, we are providing the bearing coat over this layer. So what's that value? So if you observe clearly, you will get this 10 centimeter bearing coat is provided here, and this values, it is going to be 2.3 meter, and the thickness, it is going to 0.1, and so the total length of this rod, it is given in the question, it is 4 meter. So you can directly take this 4 meter, then breadth, it is going to be 2.3 meter, then 0.1, you will get this 0.92 meter cube. Now our aim is to calculate the quantity of plastering required for this brick masonry. Okay, so how much amount is required for this brick masonry construction? So if you observe, or for easiness, we are considering this much portions, this total length, it is going to be 4.7. so from this bottom portion, from this coping onwards to the bottom of this surface, that is, if you observe here, you will get 1.3 plus, then here 20 centimeter, that is, so it is going to be 1.5, and here it is going to be 60, that is going to be, if you take only up to this coping portion, then it is going to be 50, so you will get 2 meter. And we are going to consider a 10 centimeter also, this ground line also, below this ground line 10 centimeter also to be considered. So you will get the value in this way, that is, the numbers, it is going to be 2, since both the sides we have to consider the total amount, that is 2, then the total length, it is going to be 4.7, then total height 2.1, so you will get this value. And also check out this cement pointing 1:2 involves face wall from 10 centimeter below ground line up to bottom of coping. Okay, so we need to calculate up to this much, and finally after calculation all those calculations we need to reduce some portions that we will discuss later. And if you observe here, so our aim, already I mentioned that we need to plaster all these portions like this one, this area, this, likewise all these areas we need to plaster. So our next aim is to calculate what about these areas. So actually already I mentioned that in the calculation of central line methods is this plastering, everything is related with the meter square meter. Okay, so the area we have to calculate. So if you observe this height, it is going to be 0.2, then it is going to be 0.1. So this height is going to be 0.5. So total it is going to be 0.8, isn't it? And the total length it is going to be 4.7. So inner side of parapet excluding coping. So the top portion actually we didn't mention in this case. So inner side of parapet excluding coping, it is going to be two numbers, both the sides we need to construct, and the height it is going to be 0.8, and you will get this 7.52. Then our next aim is to calculate this coping. We are going to only focusing on this coping, that is the top portion. So if you observe clearly, that means this portion, if you want to plaster this portion, then it is going to be this portion, this much portions. And if you observe here, there is a portion, and here is also a portion is there. Okay, so if you observe clearly, you can find out that this height it is going to be 0.1, then again 40, then again 10, then again 10. So if you observe clearly, you will get the value as total. The length will be different, that is 4.9. the coping length it is going to be more, and the height it is the breadth it is going to be 0.7. you have to take. Okay, so you'll get this value. Okay, fine. Then the ends of parapet, so that will consider next one. So this is our final procedure, that the plastering we need to calculate. So if you observe clearly these values, if you observe clearly, you will get more clarity regarding. That is, this dimension is given as 0.4. This, if you observe clearly, you will get 0.4 or 40 centimeter, and height it is going to be 20 centimeter. Then 30 centimeter and 50 centimeter, that is mentioned here. And if you observe clearly, the top portion it is going to be 0.4 and 0.1, and clearly you can observe from this diagram also. Okay, so we need to calculate this areas. So this first one, that is 0.4 multiplied by 0.2, then 0.3 multiplied by 0.3, 0.5, then 0.1 multiplied by 0.4, and this side will be in this side also. Okay, the same portion will be repeating in this side, and the same case also repeated in the other side also. So total number it is going to be 4 in each cases. So if you observe clearly, you will get these values, and finally 35.08 meter square. Okay, meter square finally. And our next aim is to calculate. Actually we need to reduce, already mentioned that we need to reduce those some portions. Here a rectangular opening is provided here, and here a triangular portions is mentioned here. So if you observe clearly, you will get more clarity. This earth slope is provided here, and its ratio it is given 1:1, and its height is going to be 1.3. So both sides it will be 1.3, 1.3, since the slope ratio is going to be 1:1. Okay, and also you can visualize that this length it is going to be 1.5 meter, and if you observe this value, that is it is going to be 1.2 meter, and if you take the ground portion also, then it is going to be that is 10 centimeter also you have to add up, then you will get 1.3 meter. So now we calculate those values, that is the rectangular opening. Actually this is going to be two numbers. So and the length already mentioned that it is going to be 1.5, and the height is going to be 1.3. So if you multiply, you'll get 3.9. Then you have to also reduce this triangular portion, and it is going to happen over these 4 sides, and it's triangular, so half multiplied by 1.3 multiplied by 1.3 you'll get 3.38. You multiply this 4 also, you'll get this finally 3.38, and then you have to deduct these values from the already calculated values, and finally you will get 27.8 meters square. Okay, so this is your final structure. So if you want to calculate those portions, we need to follow these steps. To estimate this much calculations, we need to follow this much steps. So I hope the section is clear, and with this we wind up today's section. Thank you.